George Nesbitt. On the field studies, did you break out the data at all between PCS motors and ECMs? Are the results
I think
dramatically different, or?
Well, in theory, they could be. I think these were all PSE motors that we found.
Okay. To answer the one, well, I'd say yes, ban the bypass. Absolutely, get rid of it. Mike Kesey kind of asked about technology changing, and I think a lot of manufacturers now that we have, one of the solutions you say is we need variable capacity equipment, which I think the field data shows that zonal systems are actually variable capacity. They just come at the price of efficiency. So with the ECM motors and variable capacity or two-stage compressors, it seems that zonal systems are going away from bypass, or at least that would be my impression, because they can reduce the airflow to match statics and whatnot. Now, whether or not they're actually performing any better or not because of issues like not doing load calcs or duct designs, which is a humongous issue. Probably the only thing that's violated more than not pulling a building permit is not ever submitting your load calc and showing that you're meeting that standard. But anyway, so I don't know if John, have you looked at variable capacity airflow zone systems in any other studies? Are you seeing similar results or better results, or but still not good results?
Yeah, John Proctor. Brushless permanent magnet or ECM motors provide a higher efficiency, generally provide higher efficiencies of the air conditioner. And it is a way of doing multi-zoning that eliminates some of the problems associated with a single-speed machine. And we've modeled all that. There isn't a lot of measurement on it. One other thing I'd like to point out is that the question here is whether or not there is an energy savings. The reason why there's a credit in Title 24 is for energy savings, not for comfort improvement. And zone systems, I don't think anybody's going to argue a zone system can't provide more comfort. And I think that it should be sold based on that rather than a somewhat questionable claim that, or in my opinion, totally questionable claim, that on the average you're going to save any energy.
I think the answer is we haven't measured any of them, George. Okay.
Although, of course, with high static pressure, the whole energy efficiency of the airflow is but so do you actually get credit under the zonal credit on space heating currently? I believe this. So this is not an air conditioning only credit like most of the other credits that have to do with airflows or anything else.
No, this is you get a bigger setback, and it's you have to be able to zone on a heating or on a sleeping versus living zone basis, and then you're assumed to not condition the living zone at night and not condition the sleeping zone during the daytime.
Right. Okay.
So it's a very optimistic set of assumptions, I'd say.
Yeah. Well, in the whole setback, I think there's a misconception that setback thermostats are required for all conditioning systems. It's only really central systems. So if I put in a wall furnace, I don't need a setback. If I put in a mini split, technically I don't need it if I'm reading the code right. But so I've had that misconception too, but perhaps that's something that needs to be made more clear, or we just need to say all heating and air conditioning systems shall have a setback thermostat, even though I think many of us realize they don't always work the way they should. In fact, that's a whole nother discussion. On the one hand, yeah, it seems like if you do a zonal system right, you can get energy savings, but that's probably not what happens most of the time. On the one hand, it does seem like it would be nice to leave the credit, and it doesn't seem like a credit that's taken often. On the one hand, people are constantly encouraging people to do zone systems. That's one of the selling points of radiant floors is, you know, throw a zone in every room with an additional 85-watt pump, and well, there goes your savings. But so I kind of, you know, mixed feelings. I tend to, when I do zone a system, I tend to go to 2 systems, and I suspect on multi-story houses especially, it's cheaper to go to 2 systems than it is to go with all the additional controls and dampers and getting ducts between floors. But it'd be interesting to know why the multi-system zone projects were actually done that way, whether that was a cost issue or what. But so I guess, and then I guess let the clarification. So John, your clarification on the ACA results as well as your field results, those are measuring things in the same place, but are you saying that the theoretical loss in efficiency taken from the manufacturer's data was then actually taking those as different measurement points, and that's why it's a straight line and they don't match? Is that
the original model that's shown in the previous slide is an extension of the manufacturer's data tables and extrapolated. And so there's good reason to not believe the left-hand side of that, those lines.
okay? Right, so we shouldn't make anything the fact that the field data doesn't match it. But that ACA, and you agree basically with the field. Okay.
Okay, any other comments in the room on the zonal path?
Pat Slick from HapTech. First, just a couple of observations. I mean, I do mechanical design, mainly radiant out in Santa Cruz because we don't have a lot of air conditioning. And one of the reasons that we get into these systems or multi-zone systems is that the architect didn't put in place to put ducts anyway. So you can't run one duct system throughout the house. So it had nothing to do with energy efficiency or cost effectiveness or anything. It just they needed to come up with a feature to cover up their mistake. And few of the systems, I almost never I probably never have used the credit for multi-zone. But I know the few people, systems that do take credit, probably half of them don't actually qualify because they just have a 2-zone system, and they take the credit, and nobody knows that it's not right because very rarely do you have all the bedrooms clumped in one side of the building and living area in another. There's always the master bedrooms over here and the kids are over there, and it just doesn't work. So even those few that do take this credit, probably most of them don't qualify. I had a question about some other systems like high-velocity duct systems or fan coil systems where maybe you can't get that 350 CFM a ton. And have you looked at those and seen how those are affected by some of your requirements?
I think the 350 CFM per ton and 0.58 watts per CFM, there are particular things that we need to look at, such as the mini split that we were talking about and the high velocity systems. And we haven't talked about that yet.
Yeah, I run into situations where I'm putting in like first company fan coils because I can't run ducts all over the place. I may just have, usually you have to find a bathroom or something like that where you can drop a system and put a system and then you just radiate out just to the rooms right around it. So those might be very low loads. You might need 4 different systems to meet your load. But they've sort of eliminated all the really small units. To get a small fan coil, I have to basically go to a European system, and they're not really set up with all our controls. You end up having to put in transformers and fan switches and a lot of stuff, and it gets expensive fast. So if we're talking cost effective,
You're talking about a heating system only, if it's a fan coil? Right?
Mine are mostly heating, but they could be heating and cooling.
Because the CFM per ton is only a cooling requirement, right?
Well, here this comes to the next question then, and I think this is the last one. Are you considering eliminating bypass for forced air systems that are heating only? Because a lot of times what people will do is they'll put in a forced air system, especially in my area, and prep for air conditioning. So there's no air conditioning there, but they put the boxes in there for the coil.
And a bypass there.
No, they didn't actually put the bypass in, but it's set up for it, so it could be put in there. But it's not actually there. But on some of them it is there. It depends on the manufacturer. So anyway, if you don't eliminate it for the heating system, then it's going to be there when they put the coil in. So that's it.
Thank you, Pat. Any other questions, Mike?